Hey, good evening, everyone. In today's video, I'm gonna show you the part 2 of SQLDelight in KMP. And if you recall our last video, and or give you a brief introduction about how you add dependencies in the KMP project for your SQLDelight, and also define your database and table in the build Gradle KTS file. And once all of those things done, you can see here and in your Compose app and build generated and SQLDelight. And if you open this, you can see your database and your database file. As you can see, it should be a Kotlin file. Yeah, it's a Kotlin file. And for your first table, demo table, and there's a data class here, and also your queries is also a Kotlin file, and provide a few methods you can use in your code base to get records or update or insert, etc. Yeah, it's pretty much it. And if you got more tables in your SQL file, you'll be have more like table Kotlin files generated here. So yeah, and if you haven't watched my previous video, you can go to the channel and watch those videos first. It will be the foundation of this one. And in today's video, I'm going to show you how to use those tables and the query methods what you have defined for the previous video. Let me show you, and we'll also start with define the cross-platform interface. Let's go to the command main, and under your app package, and you have a database package. If you haven't got one, create one. And there will be two files here. The first one called database driver factory, and is the purpose of this file is need to create a database file, right? For example, app.db in your desktop, in your mobile phone, etc. So this will be the the physical file used to store your data in the database. So if you are familiar with this expect modifier, and also there will be a previous video and give you a brief introduction how this expect actual modifiers works in a KMP project. Yeah, I won't repeat those knowledge in this video. I'm gonna start with this one, create driver. So you have this in interface in the command main. So in different platforms, like in desktop, in Android, iOS, you would have different implementation to create these files, right? And if we go to an Android database, and you can see here is an Android driver factory, and it implements this create driver in Android, right? It's return Android SQLite driver, and you define the scheme, define passing the context, and define the name of the database. And to be noted here, this name actually doesn't matter because compared to the desktop, right? Because in Android, this file will be always under your package name file, data, and your app package, and then this file. So even you have the same file name of your database, so it won't conflicts to other apps in Android, right? And then we go to desktop. In desktop, actually, this matters, right? If you can see here, actually, yeah, I think I would like to show you two methods. The first one is a memory. For example, if you prefer your database as a memory database, you don't actually need to persistent your data and to survive the app being killed, etc. So you can use a in-memory database in this case. So here will be the example, right? And for the most cases, maybe you need to persistent your data, right, as a file. So you can see here is it goes to the directory where you store your database file, and you can also see there will be a DB file here, right? For example, for our file, we can just change a name called demo. Otherwise, if you go the same, because for example, you go to KMP applications, right? And this user home directory will be the same, right? If you have the same name of the database, and they would like conflicts to each other, right? So you need to, for desktop build, you need to have a different specific name for each application, right? Yeah, and the rest is a boilerplate. You can just copy into your app to make it work. Next one, let's go to iOS. And in iOS, yeah, actually the database is in native, right? In native driver factory is a similar one. Like you got a native SQLDelight driver, and then return the scheme and the name of the app, right? So yeah, it's the first step. Like create the database file, which actually this file used to store all of your data in the SQLDelight. Next one, and is called a database helper. Actually, this would be the bridge, like bridging your business code and to the like auto-generated SQLDelight files, right? So let's check this into more details. And it got this database helper, and this database helper will be used when, for example, by your repository or by your domain and whatever, right? So it's kind of like a interface to bridge your domain code, right? And so you define a database here, and this app database actually, if you click into that, it within the SQLDelight generated file, right? And then we go back, and then it's invoke this driver factory create driver here, right? It's kind of like the initiation of the database. And then this demo queries is a query instance for one table. If you have several tables, it will have several queries here. For example, your demo queries, maybe you have another table called student and table, you would have a student queries here, right? So you can see here, you can see only one here because you have only one table in our demo, right? Yeah. And next one is will be those methods. You can define yourself or just generate those things like via AI, right? So, but basically, like what it is this demo query. For example, if you click this, you can see all the methods actually being generated. Being generated here, right? Let me see. As you click into that, that will be the generated file as well. You can see here it's a demo table queries, right? So whatever you generated will be here. Yeah. So this would be the database helper, and yeah. And then the next step, I think, what you need to do is you need to create the instance, right? And assume that you're all familiar with the con dependency injection library, what we're using here. So I just use that as an example. I can see here we just have a singleton database helper here, and then like it will be used in our repository, right? Use that in repository, and then the repository will be used by the view model, and as you can see here. Yeah, actually, this would be come from the user case. Yeah, use case, for example, add a user, and in the repository we insert user, right? In the clean all user will clean all, and the get user will be read the username from the database, and then we just click into the demo repository. You can see here is got an instance of the DB helper, and DB helper will just call the method insert clean all and get records by ID, etc. So that'll be the how the database works in your code base. And then, for example, if we run this desktop application, you can see how it works. Yeah, as you can see here, actually this is a database, and then we got 3 buttons for showcase the database demo, right? If we click get, because we haven't added any user here, so we get a none. It's empty, right? We don't have any user data here. And if we click this one, we'll insert a record into our code base, into our table, right? It's a user MAC is added, right? And then we get, so we can get this user MAC, right? And then we can try, for example, we close our application and we rerun. And you can see here, we get this user again, we can get Mac here, right? Because it's being stored in our database. So even our application being killed, it can still available, right? It can survive. And we can give another try. For example, we clear it, and then we click the close button and rerun the application to see. Yeah, we get the user again, so it's being cleared in the database, so it's not here anymore. So it's now, right? It's basically how it works, and it works the same in Android and iOS. So it won't show it like to again. So you can feel free to play around by yourself. Okay, it is today's content, and hope you enjoy it. Thanks for watching. Have a good night.